right, welcome back. We're going to talk about some concerns that we might run into when trying to graph these integrals. And I just want to use the integral that we talked about in the last video. It's the area under the curve, a tangent of x from 3 to x, and we are told that it goes through the point 3 comma 5. And again, this is one that we looked at last time. So what I want you to do is I want you to put that in your calculator. Don't forget Math 9 gets you your integral. I want you to use a standard window, zoom standard, which goes from -10 to 10 in both directions. And I'll pause while you go ahead and do that. All right, so coming back, what you probably got is you got error, tolerance not met. And the problem that we have here is that tangent has vertical asymptotes. So depending on where you start and depending on where you're planning on ending, you run into the issue of, well, hang on a second, how am I supposed to find the area under a curve when the curve goes off to infinity? So what we need to do is we need to look at, well, what do we know about tangent and what would be an okay region? So when I think about tangent, here's what I know. Drawing my unit circle, where I've got some angle, I know that tangent is the rise over the run, and I know that tangent is undefined here and here. So pi over 2, 3 pi over 2, and what I notice is that it is undefined at odd values of pi over 2. And one way that we can write that is saying 2k plus 1, which will always be an odd number, pi over 2. So for x equals 2k plus 1 pi over 2, where k is any integer, 2k plus 1 will always be odd. That will give us a vertical asymptote. So we basically can't do this anywhere near vertical asymptotes. We can get pretty close, but we can't do it across a vertical asymptote. So the question is, where can we do it? Well, we know negative pi over 2 to pi over 2 will work. We know that pi over 2 to 3 pi over 2 will work. And so on, back and forth between our asymptotes. And then the next question would be, hang on a second, we have this point here at x equals 3. Which interval is this at? Well, pi over 2 is 1.4. So 3 pi over 2 would be 4.2, which means that this is the interval that we're interested in. We want to look at, if we draw in some of our vertical asymptotes, we want to look at this one right here, because it's the one that has the point that we have. So what we're looking for here is the interval from pi over 2 to 3 pi over 2, and we don't want to include pi over 2 and 3 pi over 2. So if you go ahead and graph that, choosing a window that's a little bit to the right of pi over 2, a little bit to the left, what you get is you get that this is what our function looks like. So what we have now is we have a starting point in the continuous domain, and if we approximate it 1.57 to 4.71, that's pretty close. But notice what's key here. What's key is that we never get to these vertical asymptotes because, of course, the integral doesn't exist at those points. One little tech tip that I will give you as well is that you can increase the speed of graphing by increasing your X resolution. Notice that when you're trying to graph this, your calculator has to calculate all these little tiny areas, and X resolution is how far apart are the points that I choose. If you increase that a little bit, it will actually speed the process up. You can go back and play with that. Try a different one and see what you get. All right. Just double checking my notes to make sure I covered everything I wanted to cover. And I believe I did. So I think we're good. All right. Have a great day.